So today we'll be going over auxiliary angles. So what is this? This is a component of trig, and it's basically somewhere along the lines of, we have a sine theta plus b cos theta, and we want to express this whole thing in terms of r sine theta plus alpha, or r cos theta plus alpha, or r sine theta minus alpha, or r cos theta minus alpha, right? These are the different options we want to define this as, which will eventually help us solve out, some value here. So let's just let this be t, okay? So essentially what we want to do is, first of all, we'd like to expand this section out. When we expand this out, we're going to get r sine theta cos alpha plus r sine alpha cos theta. Expanding r cos theta plus alpha out, we're going to get r cos theta cos alpha minus r sine theta sine alpha. And in this section, we're going to get r sine theta cos alpha minus r sine alpha cos theta. And here we have r, let's just see, r cos theta cos alpha plus r sine theta sine alpha. Just a reminder, so when we have this plus, it turns into a plus, and when we have this minus, it turns into a minus. But for cos, it's the opposite. So if it's a plus, it turns into a minus. If it's a minus, it turns into a plus. So let me just get rid of all of that. Okay, so now we have this form, right? So we can do something we call equating coefficients, right? So if we want to, for example, write a sine theta plus b cos theta into this form, right? We can then write out r sine theta cos alpha plus r sine alpha cos theta here. And we know this will equal this, and we can say this value will equal this value. So from here, what we'll get is a sine theta equals r sine theta cos alpha, and b cos theta equals r sine alpha cos theta. The cos and cos will cancel out, so we'll have r sine alpha equals b, and here we'll have r cos alpha equals a, right? And so from this, if this is our first equation and this is our second equation, then from here we can say, like, if we have 2 divided by the first equation, we'll have r sine alpha by r cos alpha equals tan alpha equals b on a, right? So from here, we'll get the angle of alpha, which we're going to eventually sub back into here, right? And the other value here that we added was the r. So in order to find that r, this r will just equal the root of a squared plus b squared. Now where does this idea come from? Right? It comes from this idea that sine squared theta plus cos squared theta equals 1. So now if we're going to multiply this whole thing by r, we're going to get this, right? We know sine squared theta sorry, this will be r squared and r squared and r squared. Hang on. Yeah, so what we're doing is in this section, we've just squared it and put it here. This is the same as 1 squared plus 2 squared will give us r squared, right? So this means that we have got now a squared plus b squared equals r squared. So r will just equal root of a squared plus b squared. Hopefully that makes sense. So now we have the value of r and we have the value of tan alpha, which will give us the value of alpha, which is just tan inverse b by a. So now if we want to use this value, right, this will just be the same as root of a squared plus b squared. From here, then we have this section, which will be sine. We want to do times sine of theta plus alpha, which we have from here is just tan inverse of b by a is equal to t. So then we know that sine theta plus tan inverse of b by a will equal t by root a plus b squared. From here we know theta plus tan inverse of b by a will equal sine inverse of t by root a squared plus b squared. Now if we had actual values for this, we can input it into here and into here, and we can find the value of theta within the given domain, and that would be it. Now obviously there are 4 of these equations, so we could do the similar thing with r cos theta plus alpha, r sine theta minus alpha, and r cos theta minus alpha. Just by equating the coefficients, we would get those values, and therefore we can essentially do the same method again for each of those. Another thing we need to consider is the fact that we're going to take a look at the unit circle, right? Or rather than the unit circle, this thing. Sorry, that's wrong. ASTC, after school to college, or yeah, that's the way I remember. So we have this one, which means all of sine, cos, and tan are positive. And here we know sine is positive, cos is, you can say, negative, and tan is negative. Here we have sine is negative, cos is negative, and tan is positive, right? And here we have sine is negative, cos is positive, and tan is negative, right? So that means that when we're taking a look at alpha, right, our alpha from this section, from the tan alpha equals b by a, we're going to have to take a look at it from these perspectives, all 4 of these. Is alpha in the first, second, third, or fourth quadrant? The way we can think about this is in the sense that taking a look at here, let me just grab another color. I think purple is a good color. So taking a look here, we know that this value, if a is positive, then cos will be positive, which means that it can either be in the first or the fourth quadrant. Assuming A is positive. Now if B is also positive, that means that it has to be in the first quadrant, so tan alpha will be in the first quadrant. That's how we know that it's in the first quadrant and not, for example, the third quadrant, because that's also where tan is positive. But for tan to be positive, and in the third quadrant, this value of A has to be negative. And this value for B has to also be negative. Now, for example, if the B is positive, but the cos is negative, and then therefore this tan alpha equals B by A will therefore also be negative. Right. So if it's negative, then that means that it will therefore be in the second quadrant, right?